In this video, we study about MCQs of Statistical Inference. This is part 2. You can find the link of part 1 at the end of screen when this video ends. If you are new on my channel Statisticians Club, please subscribe the channel. Now let's start. Question number 1. This is blank space. Is the specific value of the statistics used to estimate the population parameter? Choices are point estimator, confidence interval, estimator. The answer is point estimator, because in point estimator we have specific value to calculate the estimate of population parameter. On the other hand, in confidence interval we have the range of values to calculate population parameter. So the right answer is point estimator. Question number 2. An estimator Q of an unbiased estimator of the population parameter Q, if expected value of x is equal to mu, expected value of q is equal to q, expected value of q is equal to q. The right answer is here is repeat, expected value of q is equal to q, because q is population parameter, and suppose that q is also our sample unbiased estimator. So its expectation, if its expected value of sample statistics is equal to the true value of population parameter, then this is the sign of unbiasedness. So this is the right answer. Question number 3. Since expected value of x actually said to be unbiased estimator of population mean, the parameter of population mean is denoted by Greek letter mu, and sample, and we denote sample mean by x bar or simply x. Expected value of x is equal to population mean mu, then this is an unbiased estimator, because in unbiasedness we have the expected value of sample mean equal to the true value of population parameter. Question number 4. Sample proportion P is unbiased estimator. Remember that sample proportion P which is represented by sample proportion, this is unbiased estimator of its population parameter, population proportion. Question number 5. Sample variance is unbiased estimator of population variance, because sample variance is also unbiased estimator of population variance. Expected value of x square, here is small bracket, you can put small bracket here. Expected value of s square is equal to s capital S square. So remember that sample variance is unbiased estimator of population variance. Question number 6. Sampling error decreases by decrease. So sampling error decreases by increasing the sample size. As you know, sampling error is the difference between different groups of sample. So as you increase your sample size, sampling error will be decrease. By increasing of the sample size, your sampling error will be decrease. Question number 7. If x is equal to 40 is an estimate, so these are options mu 6. The right answer is mu. This is wrongly written. X is equal to 40 is an unbiased estimator of mu, because x is 40. If we calculate its estimation, its population parameter is mu. Question number 8. Point estimate is an estimate expressed by a single value. We read in first MCQs, point estimate, an estimate which is expressed by single value, confidence interval, point estimator. So point estimate is the single value. Question number 9. Estimate is the value of sample statistics. Because if you have a sample of observations, you want to calculate its mean, you put in a formula x bar is equal to sum of x over n. Its answer is estimate and the formula is estimator. So estimate is the value of sample statistics. Question number 10. Unbiasedness is the process of using sample information to reach population parameter. Question number 11. Estimation and testing of hypotheses are main branches of statistical inference. Statistical inference has two types. One is estimation and another is testing of hypotheses. Question number 12. The minimum variance unbiased estimator of population mean is s square over n. Question number 13. 95% confidence limit mu r. Its formula is x bar plus minus z alpha by 2. If your alpha, you set your alpha is equal to level of significance 0.05. So its stable value is 1.96. X bar plus 1.96 sigma, which is represented by population standard deviation over small n. So this is 95% confidence interval. When you calculate your 95% confidence intervals means 1 minus alpha, 1 minus 95% means your alpha is 0.05. So this is its formula. 95% confidence limit for proportion. Here your alpha is also 0.05 and its value is 1.96. So proportion p cap plus minus 1.96 under root p square q square over n. This is a confidence limit for p. The hypothesis which is being tested is called null hypothesis. First of all, we test the null hypothesis, whether it is true or false. Which of the following is sample hypothesis? Here is equal sign, so this is the sample hypothesis. This is the simple hypothesis. Greater than, less than, not equal to sign are the representation of composite hypothesis. Question number 18. Type 2 error is committed when null hypothesis is accepted when it is false. Type 2 error is committed when we accept null hypothesis when it is false. If we reject null hypothesis, if it is true, this is type first error. We reject null hypothesis but it is actually true, we perform type first error, but type second error is except when it is false. Question number 19. 95 confidence interval for proportion. We can calculate this by using formula and this is its answer. You can calculate this 95% confidence interval for p by putting value in this formula. P plus minus 1.96 p square q square over n. Which of the following cannot be H discord? This is the right answer. Not equal. Question number 21. The level of significance is denoted by alpha. If H0 stated as q is equal to q naught, the alternative hypothesis will be less than, greater than, equal to, not equal to. The right answer is not equal to. The value that separate the region of rejection and acceptance region. Critical values. Critical values are the values that are responsible to separate the acceptance region and rejection region. Question number 24. First and starting point in test of hypothesis is stating H0. In our H0, at the start of your test of hypothesis, first of all, you state your problem, which is your null hypothesis H0. Power of test is denoted by 1 minus beta. Question number 26. A quantity obtained by applying certain rule or formula is known as estimation. Estimation is a quantity which is obtained by applying certain rule or formula. For example, as you calculate mean from sample observations, so x bar is equal to sum of x over n. This is the formula where you put your values to got an answer, and this whole process is estimation. Criteria to check a point estimator to be good are consistency, unbiasedness, efficiency, all of above. These all are the criteria to check the good point estimator, whether it is unbiased, efficient, consistent. Question number 28. Parameters are those constants which occur in sample. Probability density function. In probability density function, parameters are constant which occur. So, estimation of parameters in all scientific investigation is prime importance. Estimate and estimator are different. Estimate and estimators are different. These are not the same thing. Because in estimate we got answer, and estimator is the formula to calculate, which is used to calculate the sample observations. Question number 31. An estimator is considered to be best if its distribution is continuous, discrete, concentrated about the true value. The right answer is concentrated about the true value. An estimator Tn based on sample size capital N is considered to be estimator of theta if probability of Tn, which is estimator minus parameter theta, less than very small positive value epsilon naught, and this quantity greater than equal to probability of an other estimator Tn steric, which is also minus from its parameter, and this quantity is also less than epsilon naught. So if one estimator is greater than equal to an other estimator by the same value, then this estimator of sample size n considered to be consistent. Question number 33. An estimator of parametric function tau of 0 is said to be best if it possesses all the properties of good estimator. 34. The type of estimate is point estimate, interval estimate, estimation of confidence region. These are all the types of estimate. Question number 35. If an estimated Tn of population parameter theta converges in probability to theta as n tends to infinity, it is said to be consistent. An estimator is said to be consistent if Tn of population parameter theta converges in probability to theta as n tends to infinity, so this is consistent. Question number 36. An estimator sum of x over n of population mean is. This is an unbiased estimator. Question number 37. If x1 to so on xn is a random sample from population, its mean is 0 and variance is sigma square. The sufficient statistics for sigma square is sum of I varies 1 to n xi square. So this is the sufficient statistics for random sample x1 to so on xn when the population are normally distributed with mean 0 and variance sigma square. If x1 to so on xn is a random sample from population with mean mu and variance sigma square, the sufficient statistics for mu is sum of xi. Question number 39. Factorization theorem for sufficiency is known as Fisher-Neyman theorem. Fisher-Neyman theorem is also called the factorization theorem. Question number 40. Consistency can specifically be named as simple consistency, mean squared consistency, simple consistency, and mean square consistency both. Consistency can be specifically named. We can set it as simple consistency, mean square consistency, and both simple and mean square consistency. Question number 41. If the expected value of an estimator is not equal to its parametric function tau of theta, it is said to be biased estimator. If expected value of an estimator is not equal to its parametric function, so means tau of theta is your parametric function and your expected value. We can also say that if your expected value of x bar, simply if we take the example of mean, expected value of x bar not equal to your population parameter theta, so this is a biased estimator. Bias of an estimator can be positive, negative, either positive or negative. So the answer is either positive or negative. Question number 43. If x1, x2, x3, so on xn be a random sample from an infinite population. So if x1, x2, so on xn be a random sample from an infinite population, so s square, which is sum of xi minus x bar square over n, this is sample standard deviation, sample variance. S square is sample variance. The unbiased estimator for population variance sigma square. What is its unbiased estimator for population variance sigma square? This is the formula of sample variance, sum of each observation minus its mean square over n. This is the formula for sample variance. So what is its unbiased estimator for population variance? So this is the answer, small n over small n minus 1 s square. This is unbiased estimator. Question number 44. If x1, x2, so on xn is a random sample from an infinite population, an estimator for population variance sigma square such as 1 over n I varies 1 to n xi minus x bar square is a biased estimator of sigma square. Question number 45. If x1, x2, so on xn be the values of random sample from normal distribution, its parameter of normal distributions are mu and sigma square. Mu represent mean and sigma square for variance. And s square is equal to 1 over n minus 1 I varies 1 to n xi minus x bar square is. This is unbiased estimator for sigma square, sufficient statistics for sigma square, mean square error consistent estimator for sigma square. All above. These all three are the answers. Question number 46. Simple consistency of an estimated Tn of tau of theta means limit n approaches to infinity, probability of Tn minus tau of theta greater than epsilon naught, which is very small positive quantity, is equal to 1. So this is the right answer. Question number 47. A sequence of estimated T1, T2, so on Tn of tau of theta is said to be a best asymptotically normal estimator if it's satisfied the conditions. An estimator is said best asymptotically normal estimator if it satisfied the following conditions. Number 1, under root n capital T of n minus tau of theta minus where n is 0 to 0 and sigma square and small n approaches to infinity, means it is standard normal distribution. It is normally distributed as standard normal. Tn is consistent. Tn has minimum variance as compared to variance of any other estimator Tn steric. If you have two estimator, one is Tn and other is Tn steric, so Tn has minimum variance as compared to other estimator Tn steric. So then the estimator is called asymptotically normal estimator. if it satisfies these three conditions. Question number 48. If x1, x2, so on xn is a random sample from population which is normally distributed with mean, mu and variance sigma square, and estimator which is mean sum of xi over n is best asymptotic normal estimator for mu, a consistent estimator unbiased, mean is of population when it is normally distributed is also an unbiased estimator, it is a consistent estimator, and best asymptotic normal estimator, all above. Question number 49. Which of the estimator are Bain estimator, best asymptotic normally estimator? ML estimator, minimum likelihood, and the minimum chi-square estimator. These both estimator are Bain. Question number 50. Cram-Rao inequality is based on stringent conditions. Question number 51. Regularity condition of Cram-Rao inequality are related to differentiability of function. In Cram-Rao inequality, we differentiate a function. Cram-Rao inequality with regard to the variance of an estimator provides lower bound on the variance. Cram-Rao inequality is valid in case of continuous variable, discrete variable. Cram-Rao inequality valid in both cases, continuous variable and discrete variable. If you want to see MCQs about sampling distribution, about normal distribution, first part of estimation, then click the link in front of your screen. Thanks for watching.